Okay, so we now move to the other questions. Question 7. Question 7 is simple, similar to its own tree diagram. This one we can go through. Same concept. Same concept of tree diagram. Okay, so question 8 is about cards. And this may require the knowledge of cards. So we want to discuss this one. It's usually not a fair question. I wonder curriculums nowadays are not giving such examples because it requires one who's played cards before and they know how many spades are there, how many kings are there, and so on and so forth. So, however, for knowledge's sake, you can still go through it. Refer to solutions. Refers to given solutions. We can now do question 9. Question 9. So events that have been given are A and B. A and B. Also, we've been given that the probability of A occurring is simply 1/3. Probability of B occurring is 1/2. And if A complement is A prime means the complement of A. Calculate. We now need to find the probability of A complement intersection B when A and B are mutual. When A and B are mutually exclusive. Okay, so let us now work out this question. Those in waiting room, please kindly tell them to rejoin. There's no waiting room active. Eh? It's free for all. You just join it. So it means they joined the area before they logged in. Okay, so we proceed. Let us now answer A. Well, so we are given that since probability of A intersection B is equal to 1/8. This is what we're given. So we now answer the required question. We find the probability of A complement intersection B. A complement intersection B. Okay. So we know that probability of B may be written as probability of B intersection A plus probability of B intersection A complement, isn't it? This may be written as the probability of A intersection B plus probability of A complement intersection B. So this gives us the probability of B. Similarly, probability of A may be given as probability of A intersection B plus probability of A intersection B complement. Okay, so now we can go to the next slide. We answer. We make use of this information that we already have. So now making the subject to the formula. Okay, let me see how I can question this. Who have failed to join. Okay, I hope they'll be able to join now. So we are discussing question 9. We're discussing question 9 here. So we're saying that probability of A, probability of B, I mean, is equal to probability of A intersection B plus probability of A complement intersection B. This is what we have. So we can now make some substitutions and find, yes, please.
So we can't see where you are, the screen where you're writing from.
You're not able to see the screen.
Where you're writing from.
This screen?
We can't see your screen, sir.
You can't see my screen?
No.
Okay. Are you able to see it?
No.
You're not able to see it?
No.
Now I can see it.
You can
Yes,
see
sir,
it?
we can see it.
Okay. So we are saying that. Okay, so should I start afresh?
Sir,
Yeah.
can you go back to the previous slide?
Just start again.
I've just started. So this is what is on the previous slide.
Yes, that one.
So we are saying that we have two events, right? We are saying that we have two events, A and B. Then the probability of A occurring is 1/3, probability of B occurring is 1/2. They want us to find the probability of A complement intersection B. So we're saying that when A and B are mutually exclusive events, according to the condition given in the question A, the condition is that we need to find the probability of A complement intersection B when the two are mutually exclusive. So since we know that probability of A intersection B is given to be 1/8 in the question, this is the question. This is given. And then to find this probability, we make use of the fact that probability of B equals probability of B intersection A plus probability of B intersection A complement, which may also be written in this manner. Okay, so That is what we get. So using this formula now, we just substitute what we've been given, what we have. We substitute what we have. So substituting what we have, do we have the probability of B in the question? Probability of B is half, isn't it? So probability of B is half equals. Do we have the probability of A intersection B? The probability of A intersection B, do we have it? Okay, people have gone off cue.
Yes, sir, we have.
What is the probability of A intersection B?
It's 1/8.
1/8.
It's 1/8.
Yes, sir.
Okay. So you're saying that this is 1/8. Then plus the probability of A complementing intersection B. Okay. So we're able to make the substitute the formula and say P of A complement intersection B is equal to 1/2 minus 1/8. Since you are experts at subtracting numbers, you get 3/8. So that is for part A. So continuation. Then we can now go to B. B, when the two events, when A is a, how is the question? Okay, when A and B are mutually exclusive. When A and B are mutually exclusive, okay, for mutually exclusive, the intersection is 0, isn't it? So the questions here are mixed somewhere. So okay, so let's discuss this question properly. Question 9. The information given in the question is that the events are A and B, and then the other information given is probability of A is 1/3, then probability of B is 1/2. So now they want us to find the probability of A intersection B complement. So question A must be like this: find the probability of A complement intersection B when the probability of okay, so we find this probability when the probability of A intersection B is 1/8. Okay, so for this part, so we said that probability of B may be written as probability of B intersection A plus probability of B intersection A complement, isn't it? Of which you can make the substitute, the formula, what has been given here. Probability of B, we have it. It's half. Probability of intersection B is 1/8 plus probability of A complement intersection B. So we say probability of A complement intersection B, we said it's half minus 1/8, which gives us 3/8. Then for the B part, we find probability of A complement intersection B when A and B are mutually exclusive. Mutually exclusive. Okay. So for this part, let us also work out. So if A and B are mutually exclusive, so we say since A and B are mutually exclusive, then we have that probability of A intersection B must be equal to Z, must be equal to Z. So this is the condition that we have. Probability of A intersection B must be equal to 0. And if this is the case, we have that probability of B is equal to probability of A intersection B plus probability of A complement intersection B. This gives us okay, so we can go to the next slide. So we are saying that probability of B is equal to probability of A intersection B plus probability of A complement intersection B, isn't it? So because the two events are mutually exclusive, this one is known as half. It means this guy will be 0, isn't it? This guy will be 0 plus probability of A complement intersection B. So that probability of A complement intersection B is also half. Okay. Then you can go to C. Okay, how is C? If A is a subset of B. So we find the probability of A complement intersection B if A is a subset of B. So for this part, let us make a diagram. So if this is the set B, it means A will be inside there. That's what subset means. Where A is a subset of the set B. So it means you have the universal set here. This is your universal set. Now, this set here, this set this is A minus B. The shaded part is A minus B. So this part here is A, B minus A. Okay. So that's what we have. How can we find now what we want using this information? Let us see how we can use this information. Since A is a subset of B, since A is a subset of B, and the shaded part, the shaded set is B minus A, isn't it? B minus A means B intersection A complement. B intersection A complement. That's the set that we have. So if we introduce probability on both sides, taking probability on both sides, we have probability of so we're saying that B intersection A complement is equal to the set B minus A. Then taking probability on both sides, we have probability of B intersection A complement being equal to probability of B minus probability of B, of A. Okay. Then we just substitute what we have so that we get what we do not have. Probability of B is half. Probability of A is 1/3. When you subtract A, you'll be able to get 1/6. That's the correct solution. Unless there are questions. Any question here? Okay, no question. So this is question 9, but if you look at your tutorial sheet from question 10 going down there, from question 10 going down there, this has been removed from your coverage. These are distributions. It's talking about distribution. It's second-year statistics. So the remaining is not part of your syllabus. It has been removed. So meaning that this is where our tutorial ends, and this is the end of the story sheet.
Sir, kindly send the
Thank you very
solutions
much, sir.
again into the group.
Pardon?
I'm saying kindly resend the solutions in the group.
Okay, I'll do likewise.
And
So-
sir, are we going to have maybe like another tutorial, maybe into a paper in preparation for the
Oh, the network is breaking. I
Maybe-
didn't hear you. Hello? Hello?
I was asked to
She was trying.
paper.
So in short, I'm still helping you, right? You get the point? Eh?
As in advice through a full paper, sir.
I'm still helping you, so we can revise other topics in these few days remaining. Eh? So tomorrow we are also going to meet. I'll communicate. Eh?
All right, sir.
I'll communicate the time.
All right, sir.
Okay.
Thank you, sir.
Sir, kindly send the recorded
Thank
video.
you, sir.
I didn't. I question
Thank
A.
you, sir.
Okay.